Hey guys, so we are going to continue with section 3.2, part 2. And for the first part, we learned what it was to be a relation, which is any set of ordered pairs. And in order for a relation to be a function, it needs the specific characteristic that any input goes to one and only one output. So, given a set of a relation, either in ordered pair form or graphically, we are going to learn how to determine whether it is a function or not. So, if you are given a list of ordered pairs or a table, and you are asked if it is a function or not, what you need to do is make sure that there are no repeats in your input variables or any repeats in your x values. So for this first example here, looking at your inputs, 0, 1, 2, 1, and 3. Is there a repeat in any of your input variables? If you said yes, you are correct. We have the input 1 in 2 spots, in 2 ordered pairs, so this would be no. And you would just circle your 2 repeated inputs there. Remember, you are allowed to have repeated y values. That is okay. So do not use that as an example. It needs to be a repeat in your input variable. Graphically, in math, in order to determine whether a function is, in order to determine if a relation or a graph is a function, it needs to pass the vertical line test, meaning if you were to draw a vertical line, let's see if I can do this without making something crazy here. If I drew a vertical line, and that size of line is obnoxious, I apologize, but you know, we're going to work together here. If you take this vertical line and you move it across your equation here, it can only pass the graph, this U-shaped graph, in one spot for every x value. If it passes more than once, it would be no. So in this case, this left graph here is a function. It passes the vertical line test. Let's move this vertical line over here. When we move this over here, we're good, and then it intersects at 3 locations right here. It doesn't have to even do 3. All it needs is to intersect at twice. So even if you move this one over here, and it intersects twice in blue, here and here. So only in one spot, doesn't need to be twice, but here, the red 3, it does not pass our vertical line test. Here or here, so this one would be no. There's repeated x values. So in roster form here, in our ordered pairs, we can't have a repeat in our x values. Graphically, we can't have a vertical line intersecting your graph more than one spot, anywhere. In this case, on the right, it happened a lot of times. I just showed you 2 different examples. All right, in equation form, our domain are our x values. There are things called domain restrictions. There are things in math that cannot happen that make your equation, or if you're trying to simplify a equation or an expression, you get an error message. In math, the 2 that stand out to me and the 2 that we're going to focus on right now in this section are, you cannot divide by 0, so there can't be a 0 in the denominator, and we can't take square roots of a negative. So hit pause and write those down. All right, so let's look at coming up with domains here. All right, so in this first one here, part A, it is easier to state what the domain restrictions are than for us to sit here and tell us every single thing that the domain can be, because we're going to do that all the way until the end of time, because there are infinitely many numbers that we could plug in. However, there's a finite number. We can count it, how many values of x make our domain be restricted. So in this case, this is a rational function, meaning a function written as a fraction where we have a variable in the numerator and a variable in the denominator. So when we see that, when we see a fraction and we see a variable in the denominator, we automatically say, oh, we can't divide by 0, so off to the side here, our domain restriction we're going to find it. We set the bottom equal to 0. So in this case, 3x plus 2, when does that equal 0? Let's solve this out. Subtract 2, divide by 3. So when x is negative 2/3, when we plug in negative 2/3 into both the numerator and the denominator equals 0, and the calculator screams at us and says, error, can't happen. So this is the restriction. So when we are asked to say what is the domain, our domain will be all real numbers except when x equals negative 2/3. So let me rephrase and go back. When you have a variable in the denominator, to find the domain restriction, you take the entire denominator and set it equal to 0, and you find the restriction. Don't worry about the numerator. Then, your domain, you write all real numbers except for any value of x that makes the denominator equal 0. So it doesn't always have to be 1. It could be a few. Or you might set the denominator equal to 0 and it never happens. So then that means that your domain is going to be all real numbers because it does not have a domain restriction. So hit pause, look at these steps here, and write this specific example down. All right, now let's look at the second case, when we cannot take a square root of a negative. So for g of x, notice I'm using the letter G. That's perfectly fine. You can use any letter in the alphabet to identify your function. So in this case, we already dealt with f of x. So to make it less confusing, I just chose a different variable. You're allowed to do that. So g of x is a function. G of x just means y equals the square root of 4 minus x. So one of our rules said we can't take a square root of a negative. So for the square root ones, when we have a variable under the square root, we find our domain by taking the radicand, whatever's inside the square root, and setting it greater than or equal to 0. We make our own new inequality equation. We make our own inequality, I should say. So in this case, always set it greater than or equal to 0. The smallest thing that the square root can be is 0. So we need to find the values of x that make the square root 0 or bigger. So solving this inequality, I'm going to move x over. So 4 is greater than or equal to x. So our domain is going to be x is less than or equal to 4. Once it's bigger than 4, we would get the square root of 4 minus a big number, and then that would be negative. So in this case, our domain is x is less than or equal to 4. Hit pause, come back and watch either of these two examples here to help you learn how to solve for the domain restrictions and in turn learning what your domains are. I hope you guys have a great day. Let me know if you have any questions. Thanks, guys.